So hello guys, how are you? So welcome to Small Steps Academy, and in the previous class we learned about business dilemma, weakly dominated strategy, and the difference between dominant strategy and the Nash equilibrium. Okay, so in this class we will be starting our class from our first topic, which is sequential game. Okay. Okay guys, so first of all, what is sequential game? If I tell you by the example, it's very easy, and I have already told you also this. Like, if I give the example chess and Ludo, which is famous in these days, in the days of quarantine, Ludo King is very famous. So, so the chess and Ludo is the example, and you may have got the idea of what is the sequential game, but I'll still tell you the definition and what is it. So it refers to the game in which players moves in the sequence, responding to each other's action and reaction. So how does it differ from the simultaneous game? It's easy. It differs from the simultaneous game in the sense that player that moves later in this game, like if we are playing chess, so if I move later, the second move is mine. So I have known what you have played, so I can play my move accordingly in the best possible action. So there is an advantage of to the one who moves second in case of chess only. I'm not saying in any game. There are some games in which there are first mover advantage also, so there is no hard and fast rule. So the what the player can do, the player can use this information to make more sophisticated strategy. It's obvious. If I know the move of my competitor, so I will make my strategy accordingly. Okay, so now your sequence game is over, so we move on to second topic now. There will be part of sequential game, and it is one of the part, you can say. Second is product choice problem. Okay guys, so what is product choice problem? So I will start this with an example. So there are two shops, Ram Sweets and Sham Sweets. Okay, so Ram both have the incentive to introduce product sweet. So there is one product sweet and another product crispy. Okay, like you can say one product is Kalakand and the crispy other product is aloo bhujia. Okay, you can learn like this also. So however, when both introduce the same product, they will lose money. Like if Ram introduce crispy and Sham also introduce crispy, they will lose money. If Ram and Sham both introduce sweet, then also they will lose money. Okay, and so if I make the game, that is the payoff matrix, so it will be like this. So here I am taking, this is A, I am taking A, this is B. Here it's crispy, here it is sweet. Similarly here it is crispy, here it is sweet. Okay, so I have already told you if we introduce the same product, they will lose money. So I am writing it -5 -5. Same with this also. Okay, and if one introduce sweet and the other introduce crispy, so the one who introduced sweet will have more profit than the one who introduced crispy one. Okay, so I am taking the example of 10-20. Like if B has introduced sweet product, so he will be getting the profit of 20, and the other one, if he introduce crispy, then he will get 10. Similarly, if you see it from his point of view, it will be 20, 10. Okay guys, So till here game is over. So now we move further. So what happens in a strategic move? One player announces its product first. So one player, like we will take A. A will announce its product first. Announces first. So the announcement which he will be going to do will create a constraint for B. Right? He is announcing first. So whatever he is saying, he is creating the constraint. So now the constraint which A is creating on B can be empty and can be credible. Like we can say we say it as threat. Like A is moving first. A is saying that I will produce sweet. So this is a threat. Okay. So now the second part is that the threat which A is giving, like the threat is that A is introducing sweet. And the second part is the threat can be empty or credible. Empty or credible. So now what is empty or what is credible? So okay, so let's again begin with the example. So in this example, they both two are there to maximize their profit, right? So if A announces that I will introduce sweet, A announces that I will introduce sweets. Okay, so what B thinks, B has this matrix. What B thinks that he has still option of crispy. You can see he has option of crispy. He is getting something rather than zero, right? Like there is some incentive, maybe less than this, but there is still some incentive. So it is the empty threat. It won't affect the decision of B. Okay, because it has more obviously, but it also has some incentive. So B will always think that I will go for sweet only so that my profit will also be maximized. So these type of threats which do not influence the decision of competitor, like the threat which A has given, he hasn't influenced the decision of B. So these type of threats are known as empty threats. Okay guys, so let's move on to the credible threats. So what do we do to make this threat credible? Okay, so there can be one thing, like what A can do. What A can do is, like they can start ordering only sweet raw material. First thing is that means the matrix will change into the matrix now. Crispy sweet, A, B. Okay, so first the original matrix is this. Now what A has done is that A may have stopped the production of sweet. Like he may have stopped the production of sweet. Crispy. He may have stopped the production of crispy because he is announcing that he will be producing sweet. But in the matrix you can see that there is still scope for crispy also. So it is an empty threat for B. It hasn't affected the decision making of B. It hasn't influenced it. Okay, but now what A can do to make this threat credible and take out the maximum profit from it, so that B is helpless to produce the crispy one, and this will be the solution. So how this can happen is that I have told you some of the example that first is he can shut down the production of crispy, shut down the crispy plant. Okay, the second is that he can start ordering only sweet raw material. So he will know that he has only sweet raw material. So he is definitely gonna produce sweet. So he will produce crispy only so that he also gets something. Okay. So he can do this thing, or reducing alternative decision outcomes and thereby changing the payoff. So you can do anything. I have just given you the example. You just have to make B believe that you are going to produce what you have announced first. Okay, so in this case A has announced sweet first. So if if A shut down the production of crispy products. So what will be the changed payoff matrix? It will be 0 and it will be also 0 because he is not producing sweet anymore now, and from the side of B it will be same and sweet will remain same. He is only producing sweet now. So as you can see, now if A says he will introduce sweets, so now this threat is credible because B can see that in the payoff matrix that he's not producing crispy one and he has no raw material for crispy one or whatever the reason may be. So now B has surety that A is gonna produce sweet only. So now this threat is credible. Okay, this threat is credible. Now B knows that A will introduce sweet, so now B will choose accordingly, and being a rational producer, he will choose crispy one only. As you can see in the matrix, minus 10 is greater than minus 5 because he is only left with two options, crispy and sweet. So if you see here, and A will play sweet only because it is a credible threat. Now it was unsure that A will move sweet or crispy, but here it is sure because if you see the payoff matrix, the crispy one entries are 0 0 because he had shut down the crispy production. So now this thread is called credible thread and this thread was empty thread. So I hope you have understood this concept, and I'll give you just one more example that how would you convert a empty thread into credible one. This was also the example, and this is a important topic for exam. It's a hot topic for exam, so learn it properly. Okay, so we take the previous example, you know, about wife and husband movie and concert. Same example we did before, if you remember, and if you are studying daily. Wife and husband. Okay, and you know the payoff matrix 0 0 0 0 1 2. So now husband is giving threat to wife, which is not possible these days. Okay, so husband is saying that he will go to movie, but wife is still so smart, he knows that he have option for concert also. So by seeing the payoff matrix, wife is not gonna believe that, and husband may be better off and may not be better off. Okay, so this is the empty thread. Husband for movie. Okay, so now to convert it into a credible one. So now he is converting into a credible one. Now same thing here and here. Okay, so now what will husband do? Husband is giving threat that he is gonna go to movie. So husband will have to play this and make sure to make believe the wife that he will go to movie and not to concert. So here you can see that if you take it as number of tickets, so husband have one concert ticket and wife has two, and here husband has two movie ticket and wife has one. Okay, so what husband can do to make this threat credible is that he can tear off the concert ticket. Simple. If he tears off the concert ticket, it's obvious that he is gonna go to the movie only. So to make the threat credible, he will tear off the concert ticket. So what will be the new payoff matrix now? 0 2. So now wife knows that he will go to the movie only, and wife has now no option since wife is also rational, so she will go to movie with him. So husband wins in this game. Okay, just by having some little bit of knowledge. So guys, the product choice problem ends here, and this is an important topic. You should pay attention to this topic, and every topic is important. We cannot say that this is gonna come in exam and this will not come in. So you should study every topic with same enthusiasm and with same dedication. Okay, so now we will move on to our next topic. So our next topic is mixed strategy. Mixed strategy. So what is mixed strategy now? So let's play this mixed strategy game. So guys, it refers to the strategy in which players makes a random choice between two or more possible action based on the set of probabilities. We haven't introduced probability yet. The players were moving either this or this, and there was no probability like the player is moving this one with a probability of 1 by 2 and other one with the probability of 1 minus 1 by 2, that is 1 by 2 only. So in this part, in the mixed strategy, the player is using the probabilities and everything is same, but the process of doing question now changes. Like, how do we do the questions now? I will teach you that. So it differs from the pure strategy. And what is pure strategy? Pure strategy is the one where player makes specific choice or takes specific action. Okay, so there are some cases in which we use the mixed strategy. So if I tell you the first one, the first is you know that some gave him no Nash equilibrium in pure strategy. I have showed you in the first class only that there are some games which do not have Nash equilibrium. So in these games we have Nash equilibrium according to the mixed strategy. Got it? Like in the game which have no Nash in the pure strategy, so we have Nash. So in such games with the mixed strategy, when we introduce the probability, we get the mixed Nash, which we say mixed Nash equilibrium. Okay. And second, strategies involving randomization are quite natural and familiar in sports and setting question paper. Okay guys, you got it now? Like if you are playing a football game and you have given a free hit, like you have given some goal, or when you are given some penalty. So being a goalkeeper, you have some probabilities that he's gonna kick this side and with the probability like 2 by 3, or he's gonna kick this side of probability 1 by 3. Then he quickly makes the decision. So it is mostly used in sports strategies and also in setting the question paper. Okay, and third one is that which games are complicated games. Like there are many games which will be very much complicated. I'll teach you afterwards. There will be a game tree and it will become very much complicated. So these are the game in which like one or other action is better for the player. Like they are really complicated ones. So in the complicated games we use such strategy. Okay, so now I will start off with the example. Okay, and we will stick to our wife and husband example. Wife, I'm writing wait, movie, concert, husband, movie, concert. Okay, and the same example 2 comma 1 0 0 0 0 1 comma 2. Okay guys, so now let us assume that wife will choose movie with the probability of W. So similarly, wife will choose concert with the probability of 1 minus W, since the summation is equal to 1. Similarly, husband, we are assuming that husband will go to movie with the probability of H. So he will go to the concert with the probability of 1 minus H. Okay. So if I see this question with the pure strategy, so we have two Nash equilibrium, that is, one is movie when H and W is equal to 1, both are 1, and both are 1 or 0. So when both are 1, then this will be your Nash when we are in pure strategy. And when H and W are 1, if you put here value, it will get 0 0. So you get the second value concert. So these two will be always the Nash equilibrium in the pure strategy. Okay. So now what do? We take their expected payoffs. Okay guys, so first we take for the husband, expected payoff for husband. So what it will be equal to, I'll tell you. So first is that husband will go to the movie with the probability of H, right? And wife will go in movie with the probability of W. So here if we are taking husband first, so we will take first outcome first and multiply up with the both the probabilities. 2HW. Okay. Now second one we will go to concert. 4 will come. So second one we go to concert. It's 0 into H. And what is for wife? For wife is 1 minus W. We have to consider both. So because we have to maximize the expected payoffs. Okay, so 0 into H into 1 minus W. Similarly, if you go here, it will be 0 into 1 minus H into W plus 0 into 1 minus H into W plus last is 1 into 1 minus W into 1 minus H. So 1 into 1 minus W into 1 minus H. Okay, so if you solve this, you will get 3SW plus 1 minus H minus W. So you will get this. So what you have to do now, you just have to maximize it. So what do you do for the maximization? You do the derivatives. So I am using the partial derivative now. Okay, since we are taking W as a constant. Okay, so it will come is equal to 0. We will put first derivative equal to 0, and this will give our W is equal to 1 by 3. Okay, so similarly, if you calculate your you have to calculate for wife now. I will give the conclusion at last. First we do the calculation part. Okay, so expectation of wife. So this will be the same, that 1 into H I am writing quick because you know now what we have to do. Now in wife we have to see the second element. It's just, and other thing will remain the same. Okay, plus 0 into 1 minus H into W plus 1 minus H into 1 minus W into 2. Since here 2 into 1 minus W into 1 minus H. Similarly 0 into W into 1 minus H. Okay, so it's this. So if you solve it, I'm writing the answer. If you solve it and go to do all this step, you will get your H equal to 2 by 3. You should solve it at home. You don't leave the English. I am just leaving it for you because it's just plus minus. Solve it at home. So what does it tell now? So if it tells that if wife go for a movie with probability of 1 by 3 and go for the concert with probability of 2 by 3, then expected payoff of husband will be maximum. Cool? Because you can see also from here, you are getting W is equal to 1 by 3 and W is for movie for wife. So if wife go for movie with the probability of 1 by 3, so it means that husband is it means that he is going to consent with the probability of 1 minus 1 by 3, which is 2 by 3. Then only the expected payoff, this was of husband, expected payoff was of husband will be maximized. Similarly, if husband go for movie with the probability of 2 by 3 and go for the consent with the probability of 1 by 3, then expected payoff of wife will be maximum. So this is it, guys. Now if I show you in the diagram, what is this? So this can be W, this can be H. These are the probabilities, H, small h, okay. So this is 1 1, this is 0, and I am taking W 1 by 3 here, and here similarly 2 by 3 will be. So 2 by 3 will be, take it something here because it will be bigger than this. So you meet them, you meet these both the point. So this point, this is your Nash mixed one from mixed strategy. And similarly, if you join 1 comma 1, so this point and this point is your pure Nash, which I already told you, right? So you can see also now. So this is it for all the class. In the next class we will discuss some more question of this, and we will move on to our new that simultaneous game and extensive form of a game. So that's it for today's class. Have a good day, guys, and study regularly and study hard, and you can do it. I have full faith on you. Okay guys, bye.